To find the area and perimeter of sectors of circles can be quite challenging. The key information we need is actually the angle size, because we need to find the ratio of the angle size. We can see in this case that this first sector of a circle, or pizza slice, is actually a quarter of a circle. So we probably quite simply think, yep, area pi r squared divided by 4. And you would find the area doing that quite simply. But as you can see with this bottom one, isn't always a semicircle or a quarter of a circle. So we need to find another way to get around that, or to work out the area of a circle. In this case, it's actually the ratio of the angle size. So if we look at how many degrees there are in a full circle, there are 360 degrees in a full circle. If we look at this part that we were just trying to find then, the area, we're trying to find a quarter of that. You can see with the angle size in there, it was 90 degrees. So we're actually trying to find 90 degrees of 360, or the ratio or the fraction of that size. If you simplify that, 90 over 360, it is actually a quarter. So that's where we get the dividing by 4 from. Finding a quarter is the same thing as dividing by 4. So simply, to find the area of a sector, we just need to use the same formula as before, pi r squared, but we need to multiply that by the fraction of the circle size that we have. So we know that there's 360 degrees, and as long as we're able to find the angle measurement, and this is another sign for showing the angle measurement, we need to find the angle measurement, we can work it out. So this one was 90 over 360. Sometimes you can simplify the fraction and make it a bit easier. That is how we'll work it out. You could do the same thing for the circumference. So in this case, you could use the 2 pi r times by the ratio of the angle, or the fraction of the angle of a full circle. Let's have a look at this second example. You can see that the sector size here we have is 30 degrees. So we're going to do pi r squared times by the fraction of the angle, or the ratio of the angle size, out of 360 degrees of the full circle. So pi r squared times by 30 degrees over 360 degrees. That's our angle size. You might be able to see that we're able to simplify this fraction straight away. 30 is a fraction of both, so 30 divided by 30 is 1. 360 divided by 30 is actually 12. So I actually know that this is, in this case, pi r squared times by 1/12 can make it a bit easier. And then we know timesing by 1 won't change anything, so it's going to be pi r squared timesing by 1/12, the same thing as dividing by 12. So that is what we're going to do to work this out. In this case, we're given the radius of 36, so we could put that into that formula to work it out. So if you do on your calculator, and I've just done it now, pi times by 36, because we know that's our radius squared, and then divide it by 12, the answer is actually 339.12 centimeters squared. We could have also done the same thing to find the perimeter of this sector. We could do pi, or 2 pi r, divided by 12, or times by 1/12 by the fraction, or times by 30 over 360, that's going to be the same thing. And then at the end, add the radius twice to give us these two little parts. So same idea as doing the quarter or half of a circle. We'll show a couple of examples of this now. Let's first take a look at the area. So the area of a whole circle, pi r squared. But in this case, we are going to multiply it by the angle over 360, because that is how many degrees there are in a full circle. So we know in this case that the angle is 150 degrees, so it's going to be pi r squared times by 150 degrees out of 360 degrees. That's the fraction. If we simplify that, it's actually going to be equal to pi r squared times by 15 over 36. Or we can actually rewrite that as pi r squared times by 15, all divided by 36 with our knowledge of multiplication of fractions. Let's now go and sub the numbers in. So it's going to be pi, which is 3.14, times by 12 squared, which now is going to be 144, times by 15, all divided by 36. If we then go and plug that into our calculator, so 3.14 times by 12 squared times by 15 is equal to 6,782.4. Divide that by 36 is going to be equal to 188.4 centimeters squared. To then work out the perimeter, we're going to use the same theory. So in this case, we have a radius given, so we use 2 pi r. And in this case, we're going to need to multiply it by the same thing, 150 over 360, which was 15 over 36, to get the fraction, or this fraction right here, of the circumference. So then let's plug that in. 2 times by 3.14 times by 12, all times by 15, and then divide it by 36. If we then go and work that out, we end up with an answer of 31.4 centimeters. In this case, we have then missed these two parts. So we need to go and add that on. So that's 12 centimeters and 12 centimeters. So we need to add on 24 centimeters, 24.0 centimeters. So if we then go and work that out, it is going to be equal to 55.4 centimeters for the perimeter of this sector of a circle. Let's show one more example. Let's do the area first. Area is going to be equal to pi r squared, all times by the angle out of 360 to find that fraction of the circle we want. So in this case, the angle is 45, so it's going to be equal to pi r squared times by 45 over 360. It then doesn't actually matter if you can or can't simplify the fraction. You could use this and still get to the right answer. I know that 5 is a factor of both of these. I actually know that 45 is a factor of both of them. So if I divide both by 45, left with 1, 360 divided by 45 is actually 8. So in this case, 45 degrees, you're actually finding an eighth of the circle. I knew that with 45 degrees, knowing that it was half of 90. So I could see that straight away. But if you didn't see that, you can just use the same theory as we did before and times pi r squared by 45 and then divide it by 360. In this case, I knew that it was an eighth, so I can just do pi r squared. Could do times by 1, but it'll run the same, divided by 8. So in this case, it is going to be pi times by the radius squared, pi being 3.14, sorry, all divided by 8. So if I then do 3.14 times by 4 times by 4 again, and then divide it by 8, it is going to be equal to 6.28 centimeters squared. So same thing for the perimeter of this shape. 2 pi r would give us the perimeter or the circumference of a full circle, but we know we only want the eighth of the circle. Or, in this case, maybe let's actually do to show you that it still works, 45 over 360. So in case I didn't know or I couldn't simplify it to an eighth, that fraction. So in this case, 2 times by 3.14 times by the radius, which is 4 centimeters, times by 45, all divided by 360. The reason why this doesn't matter is because you're still plugging in on the calculator. So 2 times 3.14 is equal to 6.28. Times that by 4 is 25.12. Then times that by 45 will give you 1,130.4, all divided by 360. Will give you an answer of 3.14. Interesting. Let's come back to pi. In this case, we have missed. We've only just found the perimeter of this part. So in this case, what we need to do is we need to add on 4 centimeters down that side and 4 centimeters down that side to get the perimeter. So add on another 4, or the radius twice we've done before, is actually adding on 8, which will give us 11.14 centimeters. If we had have used the other method and have gone 2 times by pi, which is 3.14, times by the radius, which is 4, and then just divided that by 8, knowing it was an eighth of a circle, we would end up with 2 in this case times 4 is 8, times by 3.14 divided by 8. You can see that's how it is, 8 divided by 8, giving you 1, so it was 3.14. Then if you add the 4 and add the 4 again, you would have got to the same answer of 11.14 centimeters for the perimeter of this sector of a circle.